So in this next gas law problem, we're solving for moles. So again, we know that if we're solving for moles, we have got to use PV equals nRT. So we're going to start again with our PVnRT, and we're going to look at this, and it says an unknown quantity of gas at a pressure of 121.6 kPa. So we know which R value we need to use because our pressure is in kPa. The volume is 31 liters. And our temperature is at 87 degrees Celsius. Now, immediately I'm going to convert that because I know that I cannot use degrees Celsius in these problems. So to convert it, we're going to add 273 to get 360 Kelvin. And then, of course, we have N, which is what we're looking for here. We're looking for the number of moles. And then to use gas law, the ideal gas law, we need an R. So we know which R we're going to need because we have our pressure in kilopascals. So again, in this problem, we're going to use 8.31 liters kPa mole Kelvin. Okay, so now we have all of our units and we have temperature units in the correct unit. And we want to solve for moles. So in this case, we're going to take our pressure, which is 121.6 kPa, multiply that by our volume of 31 liters, and set that equal to moles, which is what we're looking for, times our R, which is 8.31 liters kPa over moles Kelvin, times our temperature, which is 360 Kelvin. Now, before we get too much further, I just want to remind you that we have looked at this before, or looked at a type of problem like this before, and we did that when we were talking about the molar volume of gas. And we said that 1 mole of any gas is equal to 22.4 liters. But remember, that was at a specific temperature and pressure. That was at STP. Temperature is 273 Kelvin, and the pressure needs to be 1 atmosphere. But since we have kPa here, it's 101.3 kPa. So because we don't have our gas at 273 Kelvin, right, it's at 360, and because we're not at 101.3 kilopascals, we're at 121.6, we cannot use this simple molar volume of gas conversion to determine the number of moles. We have to use the ideal gas law. Okay, so let's go ahead and solve for this. So let me pull up my calculator here. So 121.6 multiplied by 31, and we get 3,779.6. So 3,769.6, and that's going to be kPa times liters. And then we're going to multiply 8.31 times the 360, and we get 2,991.6, whoops, 91.6. And our unit here, well, let's take a look. Kelvin's going to cancel. And so we're going to end up with liters, kPa over mole, and that's times our x. So to solve for x, we're going to take and divide both sides by liters kPa over mole. So it's going to be 3,769.6 divided by 2,991.6, and I get here 1.26 moles. And so remember, when you're dividing by a unit, it flips around. So we see here that kPa will cancel and liters will cancel. Now over here, this would give us 1 over moles. But when you divide, remember you invert the fraction. So instead of 1 over moles, you get moles. So 1.26 moles of gas is our quantity of gas at that particular pressure, volume, and temperature.